wanted to take a few minutes to look at async functions in newer versions of JavaScript, ECMAScript. You'll see this being available in Node, pretty much all modern browsers, and it makes it a lot easier to work with promises. So what we're going to do is create a little example project and use async functions with Node and also in the browser. So first of all, let's create a promise to do something and think about that. So we'll create a little utility function that's just going to wait for so many milliseconds and then return. Now again, ES5 and later have these promises, and what they give us is a generic way of thinking about work to be done that can succeed or fail in the future. It's kind of like maybe we'll do something. So here, what happens is we've created a promise and we provide a callback function with two functions itself, which are provided as arguments. So what's going to happen is when we call res, we're going to resolve with our successful results. When we call reject, we're going to fail back with some error to indicate that we haven't successfully completed this. The promise itself is something that we can reason about, hang on to, hold on to a handle, cancel. So here, the easiest way to achieve this would be to, knowing that resolve is itself a function, we can set timeout, which will create a timeout function that's going to call this function after so many milliseconds, and that's going to be the argument of our first function. This is all kosher. So now, using the promise API, we could say so this is a promise to wait for 2000 milliseconds. With the conventional API, we would do something like it's a bit awkward, but really what we've done is we've taken advantage of a method that's attached to these promises that allows us to chain them together and do some work or call a callback function after that promise has been resolved. We can also handle the error case. By providing a second argument. Promises can be chained together. Right now, however, we're going to look at a different way to consume promises, because again, that's a little bit awkward, and Node has been kind of infamously criticized for what's called the waterfall of callbacks, where it starts to look messy because you've got this indentation, inward pyramid forming of then statements and promises working with each other. It gets fairly hairy fairly quickly. So instead, as of some of the more recent versions of ES, we now have this async function syntax. So we could do something like, again, when we're inside the context of an async function, we can now use another primitive called await. And await will allow us to wait for some result from this promise. And we can use traditional try and catch statement here, allowing for a much more conventional synchronous flow. So say we wanted to build a loop in this statement, and this is not going to in any way block the UI or cause the browser to act up. If we were to do something like this, we would be able to have an evented flow here without much of a performance hit, as so. And if we were to, on Linux, strace this, we would see that it's actually not really doing much at all. It's pretty much waiting on a poll for 99% of its function. Exactly what we would see if we were to profile this process. What's nice about this is that it allows us to work with certain promise-based flows aside from just this makeshift delay utility function we've created to illustrate promises. I'd like to also look at using async functions to consume the promises from fetch, which is also built into pretty much all modern browsers. Because we're doing this with Node, however, we are going to install, actually, we'll create the package first. Now we're going to install the package isomorphic fetch. Typecode.com hosts this JSON placeholder service, which provides a mockup API. We're simply going to grab the list of posts from that mockup API. Fetch returns a promise, so here we're going to wait for that. What it also returns are a series of functions that themselves are promises to be resolved for certain conversions or encodings on that particular object. So whether or not we were looking to return the response as a binary blob or as JSON, here we're going to do exactly that. Well, it looks like we've grabbed it. And we can see that it's a list. So if we were to iterate over it, or use the new string literal templating, noting that the object shape includes fields user ID, title, and body. We'll just print the IDs and titles here. That's made it extremely easy for us to consume a JSON-based API in just a few lines of code. We'll wrap the video up there.